Okay, welcome to acid-base balances. Don't be too afraid, it's not that bad. We're going to learn some things about it, not in such detail it's going to blow your mind. It's actually not as bad as you think it is, okay, as you might have heard it is, okay. So, there are some basic things that you do have to know, that you have to get down, or you are going to be in a little bit of trouble, okay. Kind of have to know your pH, okay? Your normal pH, or your acidity level, okay, is going to be between 7.35 and 7.45. You kind of have to know that. At least you should know the 7.4, because if you're less than 7.4, you're considered acidic. If you're more than 7.4, you're considered alkalinic or basic, okay? So acid, less than 7.4, base or alkaline, more than 7.4. Pretty much have to know that, okay? Not really a way to get around that. This formula right here is your bread and butter right here, okay? You need to know this, okay? This is how acid-base balances are all based on. So, what you have here is carbonic anhydrous in the middle, okay? So it's balancing or shuffling back and forth between your hydrogen and bicarb. Okay, so hydrogen is definitely your acid, right? And bicarb, or bicarbonate, is your base. Okay? Have to know that, or you're going to be totally messed up in acid bases. Okay? Now, you have to know that your bicarb, as you see, is being dealt with in the kidneys. Okay, the kidneys are what's making your bicarb or excreting your bicarb. Okay, your base. Okay, so kidneys, base, bicarb. Okay, acid. I'm going to, for simplicity's sake, okay, and this really works well, at least at the level that we're doing the acid bases. The acid, I am going to relate over here to CO2, carbon dioxide, okay? So if you think about that CO2 as like hydrogen, it's obviously not hydrogen, but the way they shift, okay? You think about this as also your acid that has to do with your lungs, okay? So you can get rid of acid or CO2 through your lungs by breathing really hard and really fast, okay? On the other hand, if you hold your breath, then it shifts it right back here and you get acid back in your blood, okay? So just again, because of the way they shift, it's much easier for me to remember. CO2 is basically my acid that has to do with my lungs. Bicarb is my base that has to do with my kidneys. And of course, hydrogen is the acid. Okay, so whenever that comes up, you know we're talking about that. Speaking of that, probably not a bad time to bring up the fact that hydrogen looks a lot like potassium as far as similarities go, because potassium, you'll see in like diabetic ketoacidosis, well, because of this relationship, you get a lot of potassium buildup in your bloodstream and makes it very acidic because of the relationship between hydrogen and potassium, okay? All right, so that's what we're talking about. When you talk about buffering systems, that's what this is. It's carbonic anhydrous. It buffers, it shifts things back and forth on the scale as needed, whether you need to go basic or you need to go acidic or whatever, okay? So let's just kind of start there. You should know at least that stuff, okay? Okay, let's talk about bicarb while you're getting hypnotized over here. Ooh, bicarb. Okay, we love bicarb. We live it because we need to know 24 to 28 is about what your bicarb level in your blood should be. Okay? Somewhere around 24 to 28. Depending on what you're looking at, this changes a little bit, but this is about what it should be. Okay? what does it do? Again, it's the buffer, it's the base, okay? So bicarb or base. That's what it's doing, okay? And we saw how carbon dioxide is converted to bicarb, shifting that way with your carbonic acid in the middle of it, okay? All right, unfortunately I didn't stop it, but organs involved, okay, we already talked about lungs, okay? Your lungs can decrease that carbonic acid by blowing off CO2, already mentioned that. Kidney, okay, again, the kidney is what's reabsorbing bicarb or making new bicarb from CO2 and water. Again, remember that formula, okay? Because if you remember that formula, this is all just listing it out, is all it's really saying, okay? So just remember that formula will probably be pretty good. All right? Let's talk about acidosis, okay? Remember, acidosis is low pH, okay? So if we have low pH, then we are acidic. Low means what? Less than 7.4, okay? That's what we're talking about. When we're talking about low pH, how do we get that? Well, okay, let's look at this and see what is causing it, okay? That's kind of how I look at it. You look at what is the cause of it and see if that makes any sense. So, if you have a respiratory acidosis or a metabolic acidosis, you're talking about caused by the respiratory system or caused by the kidneys or the metabolic part of it, okay? So, what do I got over here? I already said that. If I am not getting rid of the acid, and again, for my purposes, I like to say CO2 is the acid, okay? I'm not breathing heavy enough. I'm not blowing off that CO2. If I can't blow that CO2 off, then I'm stuck with it. Therefore, I'm shifting everything back to acidic, okay? So I need to get rid of that CO2 to get rid of my acid. Chronic obstructive pulmonary disease, chronic COPD. COPD is your asthma, bronchitis, emphysema, that sort of thing, okay? So if you have any of these where you're having obviously trouble breathing, it's going to lead to hypoventilation, not breathing enough, and you can't blow off that CO2, therefore you're acidic. Respiratory, because of your respiratory system. Okay, pneumonia, asthma is a COPD. Pneumonia is a bunch of water basically in your lungs. Okay, and then you can have some non-pulmonary causes. Maybe get a head injury or something like that that depresses your respiratory centers and you don't breathe very well. Okay, so respiratory acidosis. These are some of the, again, you don't necessarily have to memorize them as long as you understand them. Okay, then you can kind of figure it out. There are infinite reasons on why you can not have a good ventilation. Okay. Let's look at the other part of this where you're talking about you have an acidic state, less than 7.4, because of your metabolism, because of your metabolic reasons. Okay. Well, what are some of those metabolic reasons? Shock, sure. Okay. So you don't have enough base. Okay. I don't have enough base, which means I do have too much acid, because of cardiogenic shock. Okay, well, if I have cardiogenic shock, then I'm decreasing my cardiac output. I decrease my cardiac output, I decrease my blood flow to the kidneys, I decrease the blood flow to the kidneys, I'm not making bicarb. Okay, so I don't have enough of it, don't have enough base, now I'm acidic. Make sense? Sure, took 3 or 4 steps to get there, but you know, it's there. Okay? Hypovolemic, okay, not enough volume in your blood, therefore, like, you don't have enough fluids. Okay, we talked about why you might not have enough fluids. Again, same kind of thing. You decrease your blood pressure, decrease kidney filtration, the whole thing. All right? Neurogenic, okay, now we have decreased vasodilation. I'm sorry, increased vasodilation. okay, you could have, again, it's the same thing that we're talking about, okay? For whatever reason, you have not enough blood flow, shock, okay? Your vasodilation, your arteries get too big. You still have the same amount of fluid to push through them, but it really slows down because now you got a whole big artery with just a little bit of fluid, so it slows it down. Decreases your blood pressure, decreases your kidney filtration rate, decreases your production of bicarbonate, same reason, okay? All the same things. Okay? Anaphylactic, again, anaphylactic and septic shock. Same thing, other than now we're adding in a couple more things to the same reason. Not enough blood flow for whatever reason. Anaphylaxis is your allergic reaction, right? So you start getting basically vascular permeability, popping holes in your blood vessels, increasing the width or the diameter of your blood vessels. Same thing, dropping blood pressure. Increase your immune response because it's septic. A lot of that's going to do the same thing with the vasodilation, and therefore drop your blood flow. Okay, so again, it all fits together. Okay, diabetic ketoacidosis. Okay, a big one. I want to say, for those of you who are watching the video and made it this far, I believe, and I can't verify this, but I think that's the one I chose for your second discussion question on the forum. Okay? Diabetic ketoacidosis. Alrighty? And renal failure. Obviously, the same reason in all of these. Okay? The same reason is why you're getting acidic. You're not making enough base. You're not getting rid of enough acid, okay, on this side. Same thing. Again, you can memorize them all day long, but there's really not that much point in it. If you understand the mechanisms, hopefully you do. Okay? So let's look at alkalosis. Okay? Well, what do we know about alkalosis? That's the one where you have your pH is greater than 7.4. Wow, big surprise. Why would you do that? Why would you have too much base in your body? Well, maybe you're getting rid of too much acid. And remember, I said it makes more sense if you think about CO2 as acid just because of that big equation. Oops, what did I just do? Holy cow. Huh. Okay. If you think about it, with too much CO2, you're hyperventilating. You're just blowing everything off. You get rid of all that acid. You get dizzy and everything because you are alkalotic. You're too basic. Okay? That's how you do it. Not much more to say about that. Metabolic alkalosis. Now you have too much base. Okay? Well, how do you get too much base? Well, you vomit up all your acids. Okay, that makes sense. As everybody gets this done generally every day, gastric suctioning is another reason. Suck out all your acids out of your stomach. Okay. Diuretics. Okay. Too much base, probably because you're urinating out all of your bicarb. Okay. And acids, if you OD on acids, Tums, something like that, then sure. You're making, basically what those are is bicarb. Okay, so you're getting a whole bunch of bicarb, or base. Okay, and then hypokalemia, again, caused by diuretics, vomiting, and gastric suctioning, which we talked about before. You don't have enough potassium in your blood, and that will cause too much base for the exact same opposite reasons where having too much potassium in your blood is acidic, like diabetic ketoacidosis. Okay? Let's move on specifically to respiratory acidosis. Okay? Okay, again, this means you're in an acidic state because your respiratory system is the problem. Okay? PaCO2 is in partial pressure of CO2 is higher than 45. Okay? Again, you should know this number too, by the way. The CO2 is higher than 45. Hypercapnia, okay? Most of these usually make sense, but hyper, of course, is too much. And capnia, for whatever reason, is CO2. Okay, the other ones kind of made sense. I guess they just ran out of things to say. Okay, hypercapnia is too much CO2. Greater than 45 is going to lead you to respiratory acidosis. You got too much acid because of something in your lungs. Okay? Why? We already said that. You're not breathing fast enough and you're retaining the CO2. We already said that, right? What kind of signs and symptoms are you going to get? Again, go ahead and hold your breath for as long as you can, and you will get a headache out of that. Your vision is going to get blurred somewhere along the line. You're going to get restless, you're going to get lethargic, you're going to get muscle twitches, MM is muscle twitch, tremors, convulsions, hopefully coma, not coma, and warm flushed skin. So when you get too acidic, as in you hold your breath too long, as in drowning, okay, suffocating, these are things you're going to get before you die, okay? Usually we're talking about over a longer period of time, obviously. No one thinks, oh, I'm getting really restless and tired at the same time while I'm being choked to death. No, not quite the same thing. Okay. Compensation. How do you compensate for a problem in your respiratory system that's making you acidic? Well, you go to your kidneys, okay? And you conserve that bicarbonate. And you get rid of your acid by urinating it out. Makes total sense, I hope. Okay? Let's go on to respiratory alkalosis. Now we have a basic state because our respiratory system is a problem. Now we're talking under 35, hypocapnia. Now, because you hyperventilated, you blew off all of your CO2. You blew off all your CO2, you blew off all your acid. Therefore, you're in alkalotic or basic state, okay? Because of your respiratory system. What is the most interesting part of this? The paresthesias, or the tingling in your fingers and that sort of thing. You go ahead and try it if you like. You know, breathe like crazy, hyperventilate. You'll see that you'll kind of get tingly. Okay, paresthesias. Apparently it will spaz up your wrist if you. I've honestly never tried it. Apparently it will spaz up your carpal pedal area wrist and your whatever. Okay, so again, it's a respiratory problem. You're too basic, so you're going to compensate it by going to the other thing, the kidneys. Okay, and then you're going to conserve your acid, and you're going to get rid of your bicarb. Okay, that kind of just makes sense. Move on. Move on to metabolic acidosis. Okay, again, you have an acidic state, less than 7.4, because of a problem in your metabolic part of it, which we think about as the kidneys, bicarb. Okay, decreased bicarb, not enough base, too much acid. Okay. No pain, yeah, whatever. Okay. Compensation would be the other way. If metabolic is the problem, you compensate with the respiratory. Okay. Small respiration. That is a deep and rapid breathing to blow off CO2 to reduce carbonic acid. You'll see people, unfortunately, this is one of the things that people, when they're really, really messed up and they're about ready to die, they get the small respiration. It's like, hopefully it doesn't scare you too bad, but it's really labored, heavy breathing to get rid of as much as they can because they want to hyperventilate so that they can put themselves in a respiratory alkalosis to balance off the metabolic acidosis, if that makes sense. Okay? And of course your kidneys, they're supposed to be dealing with the bicarb, so if you are in an acidic state, then you want to conserve your bicarb, keep it in your body, and get rid of your acid. Okay? That makes sense. I hope. Okay? Other one is metabolic alkalosis. Again, you're too basic because of something going on in your body, in your kidneys. Okay, so what do we got to do? We got to increase our base, right? Duh. I'm sorry, that's what it is. You have increased base because you're alkalotic. For whatever reason, you increased your bicarb. Okay, that was a problem. Okay, got rid of too much acid. Okay, I don't know why your kidney would do that, but you never know. Okay, now you are in an alkalotic state because of your kidneys. These are the kind of things you're going to get. Again, I'm not going to really read them to you, they're right there. Compensation, okay. Well, if you are too basic, and it's because of your kidneys, your respiratory system is going to want to make you more acidic. Well, what did we say? How do you make yourself more acidic by your respiratory system? You stop breathing, okay? You slow your breathing down. That's going to make yourself more acidic, okay? Retain that CO2, which again, if I think about as acid, works, okay? Kidneys, what are they going to do? Exactly what you would think they were going to do. You're too basic. You're going to keep your acid in, and you're going to get rid of your bicarb. All right, fine. Nothing really big there. So it's not that bad, I don't think. Okay, you do have to remember just those basic things, right? So you got your, that's not writing anymore because I ran out of my power plates tonight. Whatever, I don't have a blank screen anyway. Same thing though. You know, your H2CO3 is going back and forth, your CO2 plus H2O, and that's in your lungs. I'm going to draw this as my lungs. Okay? That's getting back and forth with what? Your hydrogen and your bicarb. Okay? And your bicarb is being dealt with in your kidneys. Okay, it's a bad looking kidney, but you get the point. Kind of have to remember that concept, right? This is acid and respiratory part over here. This is basic and metabolic or kidney, okay? If you look at that, the other one is going to compensate for it by dealing basically with CO2 and bicarb. This goes back and forth, okay? Not that complicated, okay? We'll look at some case studies and let me see what else we can deal with, okay? For now, I hope it makes some sense, at least gets you started, and we'll go from there, okay?